Okay, so we are doing 17.1b, so still in 17.1, and now we're going to be solving for unknown angles. So, sorry, I want to clear that. Great. So, in the world of math, there's tons of inverses. So, if you want to undo multiplication, do division. If you want to undo a square root, square it. If you want to find an exponent, you take a logarithm. So there's all kinds of inverses. Well, in the world of trigonometry, the inverse to sine is literally written as sine to the -1, which stands for sine inverse. So just so you guys know, the word sine actually does have an E on it. That's the abbreviated form. Okay. So I wanted you to know that because that's what today's lesson is all about. We're solving for unknown angles. So if you need to solve for an angle, you need to use inverses most of the time. Not always, but use trig inverses. So trigonometry inverses are just inverse sine, inverse cosine, inverse tangent. Now, just a friendly reminder, inverses and reciprocals are not the same thing. These are reciprocals. Inverses will literally be sine inverse. There is a button on your calculator. This is sine right here. This little blue thing says sine inverse. If you want to do cosecant on your calculator, you do not use sine inverse. You use 1 divided by the sine. The reason you use 1 divided by the sine is because that's the other definition of a reciprocal. So if I asked you for what's the reciprocal of 3, that's 1 over 3. Do you see how you put the 1 in the numerator and then the number in the denominator? So if you want the reciprocal of sine, it's also 1 over sine of theta. Now I don't know if you have to put it in your calculator, but you know, the more you know, the better, in my opinion. Okay, so we're working with inverses today. Maybe we'll do a little reciprocals, I don't know, but let's take a look at it. So the first example says you're given that the tangent of theta in degrees, so notice that degree symbol, that's telling us that we need to be in degrees in our calculator. There's another angle measure called radians that we're going to work with in a little bit too, but for now we're sticking with degrees. So given that the tangent of theta equals 2 over 3, find theta. Round your answer to the nearest whole degree. Now, you guys are not going to believe this right here. This is so easy. I'm trying to solve for theta, so kind of think of that as x. If you were trying to solve for x, you need to get that by itself. So you would need to get rid of this tangent somehow. Guess how we get rid of tangent? We have to take the inverse tangent. And what you do to one side, you have to do to the other. Now these undo each other and we're just left with the angle. And that equals tangent inverse of 2/3. So you just literally have to write the tangent inverse, okay? And then into your calculator, you go second tangent of 2 divided by 3, or use the fraction option, and we get 33.69. This asks us to round to the nearest whole degree, so that's the ones place, so 6 is going to make that round up, so that's 34 degrees. Woohoo! Okay, let's try the next one. Now instead of being a fraction, this is a decimal. So we have the sine of theta equals 0.25. How do I undo the sine so that I can find the angle? I take the sine inverse, and what I do to one side, I do to the other. Now you better be following proper notation, okay? So I don't want any sloppiness, otherwise I'll mark it down, okay? You have to do sine inverse on both sides. So this equals second sine 0.25 equals 14.477. Well, look at that. I am only interested in rounding to the nearest whole degree, so I only need to look at one place after the whole degree, so 14.4, so that's going to stay at 14 degrees. So I feel like you're probably pretty brave at this point and you can handle this on your own, so go ahead and try this one. Pause the video, try it, don't just copy down what I'm writing. I'm going to do it anyways for the sake of time, but I feel like, is it really going to take you that much longer to just like pause it, try it? No, it's probably going to take you the same amount of time, and you might actually like get something out of it, right? Who knows? Sometimes I forget that other teachers use my video, so if you're not in my class and you don't know me, I'm just weird, and it's fine. But I really like math, so, you know, that's awesome. So this one's a nice, easy number. We just get 60 degrees. It's because it's part of a special triangle that we'll be talking about later. All right, next one. Let's see. Given triangle ABC, find the measure of angle A and the measure of angle B. Round answers to the nearest whole degree. So I want the measure of angle A and the measure of angle B. So I'm going to set this up. So let's go ahead and let's start with angle A. All right, and if I'm talking about angle A, this is opposite, this is adjacent, and this is hypotenuse. So we have all three sides, so we get to pick our favorite trig ratio. Do we want to do sine, cosine, or tangent? You know what, let's just do cosine. So the cosine, and I'm not going to write theta because that's not theta, that's A, equals, and cosine is adjacent over hypotenuse, so that's 7/25. Okay, so that was yesterday's lesson. Today's lesson is how do you find the angle? So what are we going to do? How do we undo the cosine that's in front? We take the cosine inverse, and what we do to one side, we do to the other. So we're going to plug that into our calculator, round our answer to the nearest whole degree, those cancel out, and A is equal to 74 degrees. So this angle right here is 74 degrees. Now if I'm going to do the other one, we got to set up this a little bit different. So here's angle B. So with respect to angle B, I'm doing this in orange, this is not opposite, this is adjacent, and this is opposite, right? So which trig ratio would you like to use, sine, cosine, or tangent? I'm going to go with cosine again. So the cosine of B equals, and that's going to be adjacent over hypotenuse. How do I undo the cosine so that we can get B by itself? I take the cosine inverse. And then I plug that into my calculator. So notice the B doesn't cancel, it's just the two cosines are being undone, and I get 16 degrees. Now you may have thought, hey Woken, I know the sides of a triangle add up to 180 degrees. So if I do 180 degrees minus the right angle, which is 90 degrees, minus the 74, wouldn't I get 16 degrees and then I don't have to do this? Hey, if you remember that, use it. Great, awesome, super fantastico. Okay, I don't care. You can do it that way. You obviously will have to do a trig function for one and show me you know what you're doing. But if you can recall this from a previous math class, that's super great for me. So use it. Okay, find the measure of angle A. So here's angle A up here. Round your answer to the nearest whole number. So I'm missing a side of the triangle, but that might not be that important, because as long as I have two sides, I can set up a trig ratio. So this is going to be opposite over hypotenuse, which is sine, and I'm finding angle A, opposite over hypotenuse. And then I'm going to take the sine inverse of both sides. These undo each other. I'm going to plug it into my calculator, and I get 58 degrees. Now, if you got a number like 158 degrees, or if you got a number like 198 degrees, even better, triangle angles have to add up to 180. So if you're getting 198, you're doing something wrong. So check them out. All right, find the measure of angle A again. Sweet. Round your answer to the nearest whole degree. This time I have hypotenuse, and since the angle A side is being touched by that, that's the adjacent, so that's going to be cosine. Cosine of angle A equals 17 over 21. So then I'm going to do inverse cosine both sides. Oh, look at that cheater way, right? Just writing it in there. It's kind of like when you divide 2 by both sides, so it's not really that bad. This is what it comes down to. So A equals 36 degrees after you punch it into your calculator. Alrighty, so now we're on the back side. Find the measure of angle A. Round to the nearest whole degree. Great. We're just getting all kinds of practice. This is adjacent. This is opposite. I don't know the third side, but for what I'm doing, I don't need to know the third side. So this is going to be the tangent of A equals opposite over adjacent. Just make sure that you fill that in properly. Tangent inverse tangent A equals the tangent inverse of 35 over 17. Those undo each other. A is the tangent inverse of 35 over 17. Boop, 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 boop. That's me plugging it into my calculator, and then when I do that, I get 64 degrees. Cool. Okay, let's see these word problems. This was like real life right here. This could totally happen to you. Your cat is trapped in a tree branch. So, you know, my wonderful artistic skills. Here's the tree, but it has this like branch, and your cat's trapped on that branch right there, okay? I'm not drawing a cat, you're cray-cray. 6.5 meters above the ground. So here's your kitty cat. I will draw just like a face-ish. And it's 6.5 meters above the ground. If you place the ladder's tip on the branch, what angle will the ladder make with the ground? Now, keeping in mind your ladder is only 6.7 meters. So here's your 6.7 meter ladder. So I'm just going to fill this in. Why not? And this question is not asking you to find how far away is the ladder from the tree branch or anything like that. It's asking you for the angle that it'll make with the ground. So I'm going to call it theta because it's not called, it doesn't, you know, you can make it A or B or whatever. Don't make it C because the hypotenuse one is always C, that guy, that right triangle. But it's with respect to this one, this is opposite and this is hypotenuse. So we drew a picture just so we could get this triangle, so we could say that the sine of theta equals 6.5 over 6.7, right? So then we want to get theta by itself, so we have to get rid of the sine in front, and the way we mathematically do that is to take the sine inverse, and what you do to one side, you have to do to the other. So I'm going to plug that into my calculator, and I get 76 degrees. Kind of a steep angle for a ladder, but it's alright. You'll be fine. Okay, real life. Save your cat. The tallest freestanding structure in the world is the 553 meter tall CN Tower in Toronto, Ontario. Suppose that at a certain time of day it casts a shadow. So here's this 553 meter tower, and it casts a shadow that is 1100 meters long on the ground. Okay. What is the angle of elevation of the sun at that time of day? So I'm going to draw you guys a quick little picture so you can see our triangle has formed. And most people think angle of elevation is this guy right here, but actually angle of elevation is right there. And here's my little picture for you guys. Whatever the horizontal is, like the horizon, this is the angle of elevation. And not that we're going to do these problems, but there is also something called the angle of depression. So angle of elevation and angle of depression all come off the horizontal axis. So this right here is the horizontal axis. The shadow is being cast by the sun. That's the angle of elevation. From the ground, you're going elevating up to the sun. Okay? So we're going to do opposite and adjacent. So that's going to be tangent. So the tangent of theta equals opposite over adjacent. Got to get the tangent by itself. Those undo each other, so we get the tangent inverse of 553 over 1100, which gives me 27 degrees. So this whole entire 7.1b is on how to find angles. The moral of the story is if you want to find an angle, you have to use an inverse sine, cosine, or tangent for non-special triangles. You don't know what the special triangles are, or maybe you remember them for geometry, but we'll get to those a little bit later.